Hello everyone. In this video, I'm going to cover the topics introduced in week 1 of Computer Science 215, Data Analytics Systems and Algorithms. So the first thing that you're going to want to do when working with these videos is follow along as much as you can. Active learning is the best way to learn. And also pause the video and make sure that you fully flush out any material that's covered so that you don't move on until you've understood the material. Very important. So that's one of the nice things about the video is you can pause it at any time. Make sure that you're staying on top of the readings, the notes, the assignments, the code being covered, and move at your own pace. Okay, so the first thing you should do is open a web browser and navigate to the syllabus. Scroll down to the course schedule and you will see week 1. So we are going to cover the topics in week 1 in this video. I highly recommend before watching the video, do the reading for that week. So this week the reading is Miller and Raynham chapter 1. So if I click on this link here, it'll bring me to problem solving with algorithms and data structures using Python on the interactivepython.org site. This is our required textbook, Miller and Raynham from Luther College. So chapter 1 is the required reading for this week, and this is going to go over the basics of Python. Now, I realize that many of you may not have written Python code before, so this may take a lot of time, or you may pick it up fairly quickly, but make sure you spend the time to go through this material and learn Python. Okay, so let's click on L1-1 Introduction. So I'm not going to go through and read all of the notes in a lesson. I know you can read them as well. I'm just going to go through and point out what are the most important takeaway points from a lesson and perhaps suggest some further reading and some further practice. And in some of the videos, I may derive some code. If I do that, make sure that you follow along. It's great practice. So every lesson is going to start with the learner objective for the lesson. So for this one, make sure you focus on meeting these learning objectives by the end of the lesson. So gain an overview of the course and its expectations, understand the details of the syllabus. We actually did this in the previous video, the welcome and syllabus video. Discuss the general field of data analytics and revisit algorithms and data structures learned in previous courses. So please read through this document. The general field of data analytics, I'm sure many of you are familiar with because you have taken Computer Science 115, which is our intro course to data analytics. The second part here, revisit algorithms and data structures learned in previous courses. So here are some data structures that you've learned in your previous courses. So in 121 and 131, arrays and lists, structs, classes, and objects, perhaps classes and objects in 131, structs in 121, and an introduction to linked lists. And in your CS2 course, 122 and 132, you cover stacks, queues, trees, specifically binary search trees, and perhaps some others. But these are the main ones that I expect you're coming into this class with familiarity. In this class, we're going to cover the following data structures: hash tables, trees, heaps, and graphs. And within each one of these, such as trees and graphs, there are going to be several variations or flavors of the data structure that we will cover. In this class, we're also going to cover searching and sorting in detail. Some of these search and sort routines you should be familiar with from your previous courses, such as linear search, binary search, selection sort, and bubble sort. I would assume that you learned those 4 algorithms in your previous computer science courses. We will cover them particularly from an algorithm analysis or efficiency approach. We'll also cover insertion sort, shell sort, merge sort, quick sort, and much later in the course when we learn about priority queues and heaps, we will learn about heap sort. So in this class, we're going to use Python. Why use Python for data analytics? There are many reasons. I love Python because it's easy to pick up. So beginners typically learn Python as their first programming language. Many of you may have worked with Python. Maybe you take Computer Science 111 here at WSU, or you transferred in with some Python knowledge. Those of you who haven't, your programming background in 131, 132, 121, 122, etc., is going to help you pick up Python even faster. It's free and open source. It's not just a very specific language, maybe for prototyping. It's a great language for everything, full stack development, graphical user interface development, data science, functional programming. It's an awesome programming language. Here are the libraries for data science that we are going to cover in this class. NumPy, SciPy, Pandas, and Matplotlib we will cover in detail. We'll also work a little bit with scikit-learn, the machine learning module. This part is important too. Lots of community support development online. Always try to figure out a Python coding problem or coding question or coding error on your own first. That's part of learning to problem solve and developing your coding skills. But at some point, if maybe you can't find what you're looking for in the Python docs or using the help commands, then definitely turn to Google. Make sure you cite any source that you use. But mostly what I want to say about turning to Google is there's a lot of community support and third-party development for Python. If you think, oh, it would be really great if I had support to maybe work with this API, do a Google search and you'll be surprised how many people have already released some kind of GitHub repository with code to do that. A lot of followers for Python. It's a really great language. I will comment on this part here, the cross-platform support for Python. So it's interpreted, which means that as long as Python is installed on a machine, Python programs can be run on it. So in general, interpreted languages like Python and Java are slower than compiled languages. So like C, for example, C and Fortran are very fast languages. In fact, a lot of numerical libraries like LAPACK and BLAS, those libraries are written in C and Fortran because they are very fast matrix computation algorithms. And libraries, or excuse me, programming languages like Python, they'll actually make calls into this compiled C or Fortran code that will make these matrix operations and these linear algebra operations very fast. So while Python itself may be slow as an interpreted language, a lot of the math behind NumPy and SciPy are calling into these very fast, very optimal linear algebra and matrix computation packages. So for data science, Python is not that slow, is what I'm trying to say. It's a great language. Like I said earlier, you will have fun learning Python in this class. So the Python distribution and IDE we're going to use is going to be the Anaconda 3 Python version 3 distribution. I'll go over how to download and install that here shortly. And the IDE that we're going to use in this class is really up to you. There are two IDEs that come packaged with the Anaconda 3 Python distribution, Spyder and Idle. I'll show you both of those. You're more than welcome to use those. But there are some more Visual Studio-esque style IDEs, a little more fancier out there. Eclipse with a PyDev plugin is very popular. Python tools, you can, I think it's coming shipped now with Visual Studio, or you can download it and install it separately as a plugin for Visual Studio, PyCharm, Wing IDE. You can use anything you want to develop your Python code. Python is interpreted, so like I said earlier, cross-platform, cross-IDE, it doesn't matter. The one thing I do want to note that if you do use an IDE like Visual Studio and Eclipse that use a project structure, make sure that you do not turn in that project structure. Make sure you only turn your .py source files, and make sure that if you are to invoke your main.py file from the command line, it is runnable, because that is how the grader will be grading your assignments. But I'll come back to all of these topics here in the next lesson where we set up the environment. So here's some review about, in general, what is an algorithm, a sequence of instructions that solves a problem. I have a really great link here to inside Google search that really gives you kind of a sense of how we need to write algorithms that are really efficient because they need to scale to large data science projects and problems. So check out this link, it's really fun. And make sure that you go through these examples of algorithms learned. These are algorithms I expect you learned in previous courses and are very familiar with them. So if you're looking through this list and you're thinking, oh man, I don't remember, how to implement a recursive solution to computing the nth Fibonacci number, then spend some time to practice and refresh on these topics because these are topics in prerequisite courses for Computer Science 215. Okay, so let's move on to L1-2 environment setup and operating systems commands. Now, this part is very important to follow along with. So for this lesson, we are going to download and install Python on your computer. We're going to walk through the basics of the Spyder IDE, and then we're going to learn some OS commands that will run from the command line. The command line is that black box. It looks kind of like this on a Windows machine. Also black or white on a Mac, or sometimes purple like on Ubuntu, a Linux distribution. So we are going to learn to work with this black box in this class. Okay, so first step is click on this link, visit the Anaconda downloads page, and download the Anaconda installer for your machine. So Windows, Mac, or Linux. So I'm running Windows, so I would click 64-bit installer. So I would click this and download it. This may take some time. The Anaconda distribution is not just the bare bones Python install that you might get from, say, python.org. It also includes many packages and libraries for doing data science and scientific computing in Python. And we will use a good chunk of them throughout this class. So go ahead and pause the video and wait for your Anaconda 3 to download. Okay, once you have downloaded the Anaconda 3 Python distribution, you should see the executable wherever you downloaded it, perhaps your downloads folder. Go ahead and launch that and click through the steps. I already have it installed, so I won't go through it, but your installer should give you some kind of dialog similar to what I have listed here in L1-2. So go ahead and click both of these boxes on the advanced options, add Anaconda to my path environment variable, register Anaconda as my default Python 3.5. Okay, when you get to the end, uncheck this box, learn more about Anaconda Cloud. We don't need to use Anaconda Cloud in this class. Okay, so you can make sure that your Python installation is complete and correct by launching Anaconda Navigator. So you can search for this on your machine and launch it. Anaconda Navigator, you'll get this green circle that'll show up here. And it will launch. So Anaconda Navigator is just a program that essentially organizes all of the programs installed with Anaconda. Okay, cool. So if this launches, then you could feel pretty confident that you successfully installed the Anaconda 3 Python distribution. So let's take a look at the default IDE that comes packaged with Anaconda Navigator. It's called Spyder, so go ahead and click Launch here. I'll pull mine up, and you should get an IDE open that looks something like this. It may look a little bit different depending on where the panels are by default, because I think I've changed mine. So on the left side is your editor. So I've made a file hello_world.py, so you can go ahead and make a new Python file and save it, maybe in Computer Science 215 folder structure or something like that in your documents. Okay, so I wrote, or I'll write it now, a very simple program, traditional hello world program. So print is used to display text to standard output in Python, and then strings can be single quotes or double quotes. Notice how they turn up in green in Spider, and print is a function, so we have open paren, close paren, and I can run this program by clicking this green play button up here or pressing F5 on my keyboard. Okay, and my output shows up over here on the right in console. Yours might show up in IPython console. I will show you how to change this. I recommend going up to Tools, Preferences, clicking on Run, and check this middle radio button in the console radio button group box, execute in a new dedicated Python console. This is nice because this will give you tabbed output. Okay, so this is going to be your output under console. Now, this is running Python in script mode. You can also run Python in interactive mode. So if you click on IPython console, I is short for interactive Python, you can go ahead and type some code, and when you press enter, this is going to immediately execute this line of code. It's very interactive, and I get hello from IPython. So IPython is really nice for testing out some, quick thoughts, or maybe getting some help on some commands, or seeing what functions and classes are available inside of a module. So let me show you a few examples of how to do this, but I do recommend that you follow through all of the examples in lesson 1-2 listed here, but I'll hit up on a few of them. Okay, so first off, there is a built-in function in Python called help, and if you pass in an identifier as an argument to help, it's going to return the doc string associated with that command, or with that class. So let's do help on print. So I run help on print, and I get some help on the built-in function print, and it shows me how I can use this. Here are the different keywords, sep, end, file, flush. So by default, the output file that print writes to is sys.standardout. So this is to the console. And then it gives a description of all the optional keyword arguments. So let's try one for example. Let's do hello. Okay, let's try end. String appended after the last value. Default is a new line. So maybe I'll do end, a bunch of exclamation marks, and then maybe 2 new line characters. And then I get hello and see this extra space here. Okay, another thing that's really nice about IPython and also in Spider is tab complete. So let's say I import the random module. Okay, and I want to see what are all of the variables and functions and classes available inside the random module. I can type a dot and then tab, and this will show me all sorts of functions or identifiers available for me to use. So maybe let's try rand range. This will generate a random number in the range, say 1 through 11 exclusive, and I get a random number 6. So this is just some examples of how you can use IPython. This is interactive Python, really great for testing out some ideas or seeing what is the interface to this new module I just downloaded or something like that. One last thing I want to show you related to IDEs is, so Spider comes packaged with Anaconda. There's also a very, very simple IDE that comes packaged with a standard Python distribution from python.org. It's called idle. You might have to do some searching on your machine to find it, but it is there. So here's my idle. If I run this, Give it a second. It's going to open up an interactive Python shell, essentially very similar to IPython, just a few less features. But I can actually run modules. So this would be like hello world.py is, let's see, is a module. So let's find it. Google Drive, Python scripts, Computer Science 215. I'm following this path up here. It's really nice. It tells me where exactly this Python module is located. And there it is, hello world.py. I open this and it shows up in another window. So let me flip the order of this. So now essentially I have my editor on my left side, just like I have in Spyder, and I have my console on my right side, just like I have in Spyder. So if I come over to run module F5, then I get this output over here. So very, very similar, F5, the editor, the shell, etc. as Spyder, but just kind of very bare bones. Either one works. These are just the two that come packaged with Anaconda. But like I said earlier, you can use any IDE that you would like. And in fact, once we learn a little bit more in this class around week 3, we are going to learn about how to write our own Jupyter notebooks, which is a different form of writing Python code versus scripting and interactive, kind of combining them into a very nicely typeset document. That will be another way we'll write our Python code. But for now, stick to Spyder or Idle or Visual Studio or Eclipse. Be familiar with how to run Python in script mode and how to run it in interactive mode. Okay, so the next part of the lesson, L1-2, is the command line. So what I've done for this particular lesson is I've added some commands and some text about those commands to get you familiar with essentially navigating your file hierarchy, your file structure on your machine from the command line. And I've parallelized this, so whether you're doing it on Windows or a Unix-based machine, you can do either one. So I'm running my Windows partition right now, so I'll walk through a few of these examples in Windows, but you really need to follow along for your particular operating system and make sure you're familiar with both Windows and Unix-based, especially the differences between the two, such as backslash versus /, drives versus root, etc. Very important. Okay, so if you're on a Windows machine, you're going to follow these instructions to launch a command prompt in Windows. If you're on a Unix-based machine, then you'll follow these instructions. So I'm just going to hit my Windows key. I'm going to type CMD, and I'm going to launch the command prompt. So here's my command prompt right now in Windows. No matter what operating system you're using, to the left of your cursor is going to essentially be your prompt, and this typically tells you the current working directory, which is the folder in which this command prompt is running. So right now this is running in a folder called gsprint in a folder called users on my C drive. Okay, so work through these examples to familiarize yourself with some of the operating system commands. So help is very important. Just like I showed you in Python, it's a way to learn how to use new commands without needing to maybe open up a web browser and look at the documentation. I'm going to skip ahead here to navigating the file system. Okay, so like I said, this prompt here tells you what your current working directory is. If you are on Windows, you can also find this out by typing cd. If you're on a Unix-based machine, you can find this out by typing pwd. So this confirms that I am working in the C users gsprint folder. Now, paths in Windows versus Unix-based machines are quite different. So each one of the different folders are separated by a backslash in Windows. Now, this backslash represents an order at which to essentially traverse through directories to locate a unique directory or a unique file. So CUsersgsprint represents an absolute path to a unique location on my C drive. On a Unix-based machine, instead of a backslash, this will be a forward slash, and there is not going to be this concept of a drive like a C drive or a D drive. Instead, this is going to be in terms of a single slash, which is called the root. Now, the word root should trigger some kind of thoughts about a tree structure that you learned in Computer Science 122 and 132. And in fact, this is one of the reasons why many people prefer to do development on Unix-based machines, is because they really were designed by computer scientists for computer scientists, meaning the file hierarchy is a tree structure, and it is represented as a tree structure in everything, including the terminology. So the fact that the top level directory in a file hierarchy is called root is not coincidence. This is a tree structure. Okay, so you might want to display some files and folders in your current working directory. On Windows, this will be the dir command. On Unix-based, this will be the ls command. So if I just type dir, then this tells me all of the folders in the directory CUsersgsprint. And one thing that is important to note is this dot and dot dot. So the dot represents the current directory, and dot dot is essentially a reference or a pointer or some kind of trail for you to get from the current working directory to the parent, the previous directory that this one resides in. So if I want to change directory, say I want to navigate into, let's do music. So I'll do cd change directory music, and now if I do a directory search, then I'm going to see all the contents in my music folder, which is empty. So I will use cd dot dot in order to back out. So see how my prompt here, the absolute path of my current working directory was CUsersgsprint music, and then I backed out by cd dot dot, which goes to the parent directory, and now I'm back up a level in Gsprint. So the rest of the commands go through creating directories, creating files, removing directories, removing files, modifying files. Particularly if you're working on a Unix-based machine, I recommend working through using Vim or Emacs to modify a text file directly in the command prompt. It also goes through copying, moving, renaming, and viewing file contents. This is important. Work through these examples, they're very important. Set permission and ownership of files. Not so important for Windows, but definitely spin up a virtual machine. You can Google VMware or VirtualBox about how to create a virtual machine if you're running a Windows machine to, run Ubuntu or CentOS or some kind of Linux distribution, to play with some of these commands in a Unix environment because they're very informative and they are quite fun. File system searching. Work through these examples, viewing the environment variables. Many of you are probably familiar with environment variables. If not, take some time and read up on environment variables and how they are used in your operating system. We already saw environment variables when we were downloading and installing the Anaconda Python distribution. We said, yes, add the Python executable to the system path, and you can see that ended up here. So C Anaconda 3, C Anaconda 3 scripts, and C Anaconda 3 library bin. So what essentially this does is this is going to be included when Python looks, or excuse me, when your operating system looks for executables. So if I'm in my command line and I type Python to launch a Python interpreter in the command prompt, it's going to search all of these directories looking for Python, the executable, so python.exe on a Windows machine, and it's going to essentially launch it in the command prompt. So see how my prompt changed to these 3 greater than signs. So now I can actually run Python code in my command prompt. And when I'm done, I can exit out of Python and return back to my command prompt. Okay, so let's move on to the next lesson so we can talk about Python basics. So I really like this diagram introducing Python because many of you have written in at least one programming language, and you're familiar with a lot of the details about that programming language, and that's going to help you pick up new programming languages. So we know that hardware sits over here as a machine language, and English natural languages sit over here. So in here are our high-level programming languages. So here's C++, Java sits over here, but even closer to pseudocode, I would say Python sits somewhere over here. So Python is going to read much more similar to English. You're going to be able to prototype things much faster in Python because you're going to be essentially actually typing less text. We don't need to declare the type of the variable. When we declare a variable, Python will figure that out in real time for us, for example. So go ahead and read through all of this document, read chapter 1 in Miller and Raynham, and we're going to work through an example that's going to walk through all of these topics in this lesson in the next video. So just one thing to reiterate, when you are learning Python or any new programming language, don't just read through these notes. Open up Spyder, open up IDLE, open up IPython, open up Python in the command prompt. Whatever flavor of Python you want to use, go ahead and open that up, and you've got to get your hands on the keyboard and you've got to be typing and following along. So I'll check back in the next video and we'll run through an example of writing a small program using all of the topics in L1-3.